Hey there, fellow coders. It's me, the Web3 Idiot. Welcome back to our series on JavaScript arrays. If you've missed any of the episodes, please go back and check them out, especially the first episode where we talk about some of the basic methods that you can call on a JavaScript array. Today, we are taking on a new challenge. We are going to rotate an array around K. Good old rhyme there, Dr. Seuss action. What exactly does that mean? Let's say we're given the array 1, 2, 3, 4, and 5. And we're given that k is equal to 2. What that means is that this here will move about. So let's go ahead, let's go ahead and copy that down here. What this means is that this 1 will move over to this, will move over 2 positions. So go 1, 2, it will move here. This 2 would move over 2 positions. 1, 2, here. This 3 would move over 2 positions. 1, 2. The 3 would go here. This 4 would move over 2 positions. 1. Oh no, it's out of bounds. So it goes back to the start. So our 4 would actually go here. This 5 would move over 2 positions. Out of bounds, which means it will be 0, 1. And it will go there. So K is how far you push elements to the right. And if they go out of bounds, they go back to the start. So let's say we have a K of 5. What does that mean? That is the same length as this array. So this 1 we go 1, 2, 3, 4, and it's actually back to the start. So if you have a k that is equal to the length of the array, it would just be the exact same array. And we'll talk about that more, especially when we get to method number 3, or approach number 3 that I'm going to explain to you. So I've come up with 4 unique approaches that you can implement, starting from easiest to, I guess, most difficult to understand. So our first one is probably the easiest one that you could introduce, which would be loop for k times. And each time what you want to do is you want to pop off the last item and unshift it into the start. So we'll go unshift a popped value. So what exactly would this do? So first up, we'd loop through k times. So let's say k is 1. What this would do is it would take this array here. It would pop off this 5. Bye-bye. And then it would unshift it onto the start. Same thing if k is 2. We would take this 4, pop it off, and unshift it to the start. So that is what it is doing. As you could probably tell if you've followed along with our series today and over the past weeks, this will have not the best time or space complexity. But we'll actually have a pretty good space complexity, but not a good time complexity. But we'll get deeper into that when we get down here to our time and space on 13 and 14. Our next one is another JavaScript array method. We would combine the powers of .slice and .concat. So what would happen is, let's say it's 2. We would go back, bop, bop, array minus 2, slice that off, and then we concat it to the start of this array. So we'd slice off this 4, 5, and concat it with 1, 2, and 3. It's pretty quick, more or less, O of n, but we'll get back to that in a second. Next, we would use a loop plus extra array plus math. So what exactly am I talking about? Basically, we would have an empty array of, we could do empty 1, 2, 3, 4, and 5. Basically, what we would do is we would say this 1, and we have this 2 here. So we say this 1 is index 0. 0 plus 2 is 2. And yeah, so that 1 would go here. Next up, we have this 2. 2 is at index 1, plus 2 will be at index 3. Oops. Next up, we have this 3. 3 is at index 2, plus 2 is 4. So we'll go there. And here, what we're going to do is also we're going to use this here, is to get the remainder. So we'll have this 5. No, we'll go to this 4. Is at index 3. So we'll have pretty much 3 plus 2 is 5, and we'll do a remainder of the length of the array. So 5 divided by 5 would be index 0. Next up, we have a 5, which is at index 4, plus 2 is 6. 6 divided by 5 will have a remainder of 1. So we have 0, 1, and the 5 will go right here. So that is how we'll use math to do it. And then finally, we have a reversal algorithm. We'll dive deeper into this once we get down to it. So let's go ahead and jump into the time and space complexities. So we'll start out with, unshifting k times. So basically, we have to unshift. And every time we unshift, we're creating a brand new array pretty much. So that will be O of n, and we have to do that k times. So this could be O, if k is 1, it could be O of n. If it is, it's pretty nifty. And then our space complexity, that would be O of 1. Pretty straightforward. Why would that be O of 1? Because we're not creating a new array. We're just keeping it inside. We're unshifting, shifting. The only thing that we have to keep track of is the value we pop off. Not popped off value, which would just be one variable. And that'd be O of 1, pretty much. Next up, let's come down to the slice and concat method. Let's see. Basically, Let's see, when we do slice and when we do concat, those will be O of n for time complexity for the slice. And then same thing with our space, will be O of n in order to hold on to the values that we're slicing off. All right, next up, we're doing our loop with our math. So let's see, that would be also O of n for time complexity. We're looping through every item in the array. So remember, we take 1, we add 2, move it forward, 2 plus 2, move it forward. Position 3 plus 2 is 5, forward, forward, forward. So that'd be O of n, and our space complexity, that would also be O of n because we are making a brand new array that we're outputting everything out to as well. And then finally, you have made it to our reversal algorithm. So that's basically O of n. We'll talk about it more in depth when we get to it. And our space complexity would be O of 1 because we're staying inside of the same array. We're just moving stuff around inside. We're going to go ahead and jump in to coding out or implementing these approaches. We're going to start out with our first one, function. We'll call this one rotate, and we'll call it unshift pop. It's a little crazy. So basically what we do is we take in array, we take in k, we'll come down here, and we do a simple for loop. For let I equal 0. I is less than k. I plus plus. And what do we do here? It's just a simple loop that we keep going through. And we say array dot push. And what are we pushing? No, we're not pushing. We're unshifting, sorry. Array dot unshift And what are we going to unshift? The item that we are popping off. Array dot, not array dot pop. So basically what this does is unshifting the part that we're popping off. So when we pop something off, it is no longer part of the array, and we unshift it, meaning we put it at the beginning of the array. Let's go ahead. That's all that it does. And of course we need to return array. So that's basically, it's very simple code, but it's not great for time complexity. Yeah, basically because of this part right here, which happens to be every time you use unshift, it is an O of n method. And because we're doing it k times, it would be n times k, which is up there. And we'll go ahead and come down here, console.log. And what are we going to do? We'll put in array 1, 2, 3, 4, and 5. And we'll put in a k of 2. So what we are expecting is 4, 5, 1, 2, 3, because we're moving everything over twice. So let's run through this array real quick. So basically the first time it comes through, 5 gets popped off, it gets unshifted to the front. Then 4 gets popped off, gets unshifted to the front, and we're done with our for loop and return the array. So over here we should expect 4, 5, 1, 2, 3. And we get 1, 2, 3, 4, 5. Wait a second. Array dot unshift array dot pop. For let I equals 0, I is less than k, I plus plus. What went wrong? I don't get it. Return array. Oh! Ha ha ha! Such a basic mistake by me. So sorry. Rotate, unshift, pop. I can't believe I did that. I'm so embarrassed. I'm not going to cut it out. I'm going to show you guys that everyone makes mistakes. And we're going to run it. All right, here we go. 4, 5, 1, 2, 3. Oh, man. Don't tell anyone I did that. That's embarrassing. Please. Please don't tell anyone. All right, we're going to go ahead and move on to our JavaScript methods, or JavaScript Array method, which is just combining slice with concat. So let's go ahead and do function, rotate. We'll do slice concat, and we'll pass it in an array and k. And then we're going to come down here and we're going to say return. Very simple. Array dot slice, and what we're going to do is we're going to slice from the back. So if I say array -1 up here, array -1, array dot slice -1, that would give us this 5. Array dot slice -2, that would give us that 5 and 4. Array dot slice -3 would give us 5, 4, and 3. So we're going to use that to our advantage. So what we're going to do is we're going to take array dot slice -k, and we will concat it, which will be connecting it with array dot slice. And what we're going to do is we're going to take the front half from 0 to array dot length, and we're going to do -k. Very good. So array dot slice, and yeah. So basically, this here, array dot slice -k, this will take the last k elements off and then put it in the front of the remaining elements that we slice off from the beginning. And let's go ahead and run it. We didn't make a test case. Oh my goodness, I am out of my mind today. I'm so sorry. I've done a lot of programming. And we're going to put in 1, 2, 3, 4, and 5, and we're also going to pass in a 2. So we're going to expect the same 4, 5, 1, 2, 3. Let's run it, and we get 4, 5, 1, 2, and 3. So remember what this does is it slices off -2. So it takes this 4 and 5, it comes out in front, and it connects with, or concats with, the 0 to -k. So remember, from 0 to minus k. We don't include minus k, but before that, everything under minus k, we'll take this. So it will be 1, 2, and 3 will be concatenated to the end of 4 and 5. And yeah, that's what we output. Our next method is our loop plus math. So we're going to come down here, we're going to say function, and we're going to say rotate math. And we're going to pass it in array and k. Bam, bam, bam. Pretty straightforward, and I think this is my favorite one just because it's fun. I know math can be fun. So we'll say let n be array.length. So this is what we will be dividing by every time, or to get our remainder. And then we'll say let temp equal new array of size n. So remember, this will just create an empty array that is n elements long. And then we'll come over here, we'll say for let I equal 0. I is less than n I plus plus. Boom, we'll come over here. Then we will say temp of I plus k. So remember, and we have to get the remainder of that over n. So remember, what we're doing is, we'll come up here, this 2, we have 0 plus 2 is 3, 0 plus 2 is 2, divided by 5 is a remainder of 2. So that would give us this position here. Yeah, so that position is equal to array at I. Maybe, let's not call it temp, let's call it maybe output. Why not? All right, and then we'll say return output. So this is creating a new array, and it is rotated around k. Come down here. I will remember to test it out before I run it, and I will remember to actually call the correct method, the correct function, 1, 2, 3, 4, and 5, and we'll rotate it 2 times. K is equal to 2. So what we're expecting is 4, 5, 1, 2, and 3. Basically what this does is it says 0 plus 2 is 2. So in this new output array, this 1 is put in the 2 position. And then remember, when we get to this 4, 4 is in the 3 position, plus 2 is 5. 5 divided by 5 has a remainder of 0, so we'll go in the 0 position of the new output. And we'll run it. Oh no! Array. Oh, sorry. Classic me. And we'll run it again. Run it back. Oh, you can't see, it's off the screen. Let's run it again. 4, 5, 1, 2, and 3. Yeah. So there we go. Yeah, so this one is just a way of getting the remainder. So I plus k divided by n has a remainder of what? And that is our new index that we give it. So remember, 0 plus 2 divided by 5 has a remainder of 2. So that is our new position for the first position, which would be here. Nice. And then our last one is our reversal algorithm. This one is a bit more complex. Why? Because there are 2 functions that we have to call. And what is our first function? Our first function will be our reverse function. So we'll call it function, we'll call it reverse, and inside we'll pass it an array, a start point, and an end point. This will make more sense in a second. And we'll say while start is less than end, we'll say array at start, comma, array at end is equal to, array at end and array at start. And then we'll say start is incremented, and we'll say end is decremented. All right, so that is our reverse function. But what are we passing in? We will be passing in the function rotate reverse. And inside we'll pass it an array and our k. So first up, we will say that we will call reverse on our array. We'll start at 0 and we'll go to array dot length minus 1. Okay, so we are reversing the entire array. Next, we will call reverse on the array, and our start will be 0, and our end will be k minus 1. We'll explain this in a second. And our last one is reverse, where array and k and array dot length minus 1. And then finally, we will return the array. I'll walk you through this after we test it, just to show you that it works. Console.log, and we'll say rotate array, rotate reverse. And inside we'll pass it 1, 2, 3, 4, and 5. And our k will be 2. So remember, we're expecting 4, 5, 1, 2, and 3. We will run it. Bloop, bloop, bloop. We'll get 4, 5, 1, 2, and 3. All right. So let's go through this really quickly. Let's talk about what happens at each point. We'll just go ahead and do it up here. So first up, we have we'll go by each step and you'll see what happens. And we'll be using this input set. So first, we pass in our rotate. We do reverse on the whole array. So from array start to the end, we reverse the whole thing. So basically what that does, it will give us a 5, a 4, a 3, a 2, and a 1. All right, so that will be our array. Next, we call the same reverse on 0 to k minus 1. So basically, we will be reversing these two here. And it will be just reversing these two here. So we have 0 and k minus 1 is 1. So from 0 to 1, that will be 4, 5, 3, 2, and 1. I think you understand how it's starting to work now. And then finally, we reverse the what is left of it, pretty much. So we'll say, oops. What happens there is that we keep 4 and 5 where it's at, and then we reverse 1, 2, and 3. Whoops. Yep, and it gets you the exact same output. Let's walk through that one more time with the number 3. So first up, we reverse the whole thing. And then we reverse 0 to k minus 1, which is 2. So this will be 3, 4, and 5. And then we reverse the last two. So it will be 3, 4, 5, 1, and 2. So yeah, it's a pretty fun method. This has a time complexity of O of n and a space complexity of O of 1. Why? Because this takes O of n divided by 2. This takes O of n divided by 2. This takes O of n divided by 2. So really it's 1.5 n, but we just round that down to n. So O of n for our time complexity. And our space complexity we keep the same array. So yeah, space complexity is O of 1. So this is the best way of doing it, combining reverse with this method that calls it 3 times on the array with different starts and end points. So if you want to be fancy, use this. If you want to keep it simple, you can use any of the other ones, but try to stay away from unshift and pop. Yeah, I hope you learned something. If you have any questions, if you're confused about any things that I talked about today, please let me know. I'll try and explain it further next time. Thank you. Bye-bye.